Hey everyone, in Creality's 3D scanner lineup, the Ferret and Autolite are built to work directly with the mobile app. That's why they come bundled with phone mounting accessories. The latest Creality Pika is also designed to work with the mobile phone, but unlike the Ferret or Autolite, it doesn't include a phone mount. There are quick release camera mounts you can use to attach the Pika to your phone, but those accessories usually run around $40. It also adds extra weight to the 3D scanners. In this video, I will show you how to make a 3D printed Pika phone mount with a hand grip using MagSafe magnet. I'm not using an iPhone, but I can still get a phone case that is MagSafe compatible. With this setup, I can attach or detach the scanner from my phone in seconds. And the hand grip also makes it easy to operate the scanner with just one hand. And this setup weighs only 569 grams, making the Pika the lightest standalone laser scanner on the market. Since the phones come in different sizes, I will demonstrate the 3D scanning and CAD reverse engineering process so you can create a mount that fits your own phone. So in this tutorial, you will learn how to model directly around 3D scan data in CAD and create your own custom accessories. First, you will need a pop grip that uses a MagSafe magnet. This one costs about $1.3. It doesn't need to be expensive since we will cut it apart and only use the ring magnet. And next, you will need a D-ring mounting screw with a standard 1/4" thread. And finally, you will need either an iPhone or a phone case that supports MagSafe. First, cut the pop grip off the ring magnet. And be careful while doing this, you still need your fingers for CAD work on the keyboard. Since the magnet housing is transparent, I will apply a developer spray to make it easier to capture in the scan. Now place the magnet ring onto the phone. We'll capture it together during the scan. Because the Pika can't scan itself, I will use the Sermoon P1 to capture the data. For reference in CAD, I only need to capture the top hand size of the phone. I'm scanning in 7-line laser mode at 0.2mm resolution, and you can connect your Pika to a PC to perform this scan as well. Next, I'm going to scan the mounting face of the Pika. For this scan, I'm using both the 7-line and cross-line modes at the same 0.2mm resolution. Scanning in cross-line mode positions the scanner further from the object, allowing it to detect more markers. In this case, it captures the size of the Pika more effectively than the 7-line mode. Next, I will export the scan project to the Creality Scan app on the PC using Wi-Fi. In the PC software, I can use the 3-point pick tool to remove the turntable. Then I fuse the point cloud at 0.2mm resolution. Then I use the single body selection tool to isolate the scan data and remove everything else. And next, I will export the project as the point cloud in ASC format. Since I'm not aligning the scan data, I don't need to run the mesh function. This is CloudCompare, one of the most useful freeware tools for managing scan data. I used 3-point picks around the MagSafe ring to align it with the XY plane. Then I rotate it from the top view to align one side with the X-axis. And here is the Pika scan. I'm picking 3 points to align it with the XY plane. Next, I will orient the Pika scan so it's correctly aligned relative to the phone. I rotate it along the X-axis by 90 degrees. And then the y-axis by 180 degrees. Then I move the Pika scan bounding box to the origin. From the top view, I align one side of the Pika to the x-axis. Next, I will move it up along the y-axis and move it toward the z-axis. Here I will translate along the x-axis to match the center of the magnet ring. Now I have enough reference data to model the bracket from the magnet ring to the 1/4" thread mount on the Pika. Then I will select each point cloud and save it as LAS format. If you are working in FreeCAD, you will need to export it as PLY instead. The aligned point cloud will retain its adjusted coordinates when saved. Next, I will import both point clouds into BricsCAD for reverse engineering. You can also model this in FreeCAD since the commands I use are relatively simple, mostly extrude and loft. If you like to follow along in BricsCAD, the point cloud is available on my Ko-Fi platform. The link is in the description. In BricsCAD, you can import each point cloud separately and then move or align them relative to one another. Here I'm using the 3-point arc to locate the center of the ring magnet. Then I create this line from the ring center along the y-axis. Here I'm trying to locate the center of the 1/4" thread on the Pika. Click on the Pika point cloud and use the move command to move the center of the 1/4" thread hole to the center of the magnet ring. I do this to keep the weight balanced so it won't rotate on its own. Next, I crop the phone point cloud so that I can create a reference for making the sketch plane. This line is resting on the backside of the phone case, and this will be the sketch plane that I will start modeling. So I move the UCS onto this line and crop the point cloud and crop it again just the top portion of the magnetic ring. Here I can identify the diameter of the ring. Next, I'm going to offset 2.4 mm for the wall thickness. And here is where the bracket will touch the magnet. And I'm going to add a 3 mm for the wall thickness. Here I select the two boundaries and use the push-pull command to push it downward here in this location. And then I select the inner ring boundary and push it upward using the point cloud as the reference to this height. Moving on to the Pika scan data, I create this vertical line. It's going to pass through the center of the 1/4" thread. Then I'm going to identify the thread location. I'm going to use the 6.8 mm for the hole size. Then I use the 3-point arc to identify the hole center. Then I match the 6.8 mm circle to this center. So now the hole is positioned correctly. Next, I'm going to create the mounting bracket for the Pika. I offset this line for 2.4 mm to create the wall for alignment. So the Pika won't turn when pushed against this wall. Then I mirror the rectangle to the other side to see the scale. And then I'm going to extrude it for 3 mm. There is a ventilation opening on the right side here. I can still extend for another 1 mm here. And on the left side I need more space for making the stiffener. So this bracket will be asymmetrical. Because I can't have the stiffener on both sides, it will be difficult to access the screw when tightening. The D-ring screw, it has 6 mm of space, so I have to thicken the wall around this area. Next, I'm going to extract the lines. And I'll join these two solid together with this sketch and extrude it to the same height as the ring magnet. Then I will union them together so that I can create a chamfer here to increase the stiffness. I move the UCS here on this plane, extract the line, and create a 6 mm radius circle. Then I'm going to extrude it for 3 mm to compensate for the gap of the D-ring screw. Next, I'm going to extract this line here along the left side and offset it by 2.4 mm. closing both ends of the sketch. Then I'm going to extrude it to create the stiffener wall. Then I'm going to union it to the main body. There's small imperfection here I can fix with the push-pull command. This will be the upright wall on the build plate, so I will use the fillet instead of the chamfer. I pull the wall back a little bit because it's too long. Then I move the UCS here, extract the line. Then I'm going to create a sketch profile for trimming it. I use the extrude surface command to extrude the sketch. Then I move the UCS plane here. And then I use the slice command to slice it along XY plane. And then I turn off the slice part visibility. Next I'm going to slice the stiffener wall using this surface. After slicing I can delete it. I turn the hidden object back on and union them. So now I have a nice trimming stiffener. I will fillet this corner so it has a parallel curve with the inner radius. Next I'm going to create the alignment wall. Offset it by 2.4 mm and pull it up for about 3 mm. This will prevent the Pika from turning when mounting on the bracket. With the push-pull command, you can always adjust the height. Make some fillet corner here. To be able to print without the support, I need to chamfer this wall. But the top part is round, so I'm going to trim it so it will look better when printing. Make a chamfer here and here as well, and also small chamfer on the mounting face of the magnet. Next, I will model the hand grip by taking dimensions directly from my hand while gripping the phone. The pinky finger extends shorter than the index finger, so I will follow that proportion in the design. After I have taken the dimension from my hands, I'm going to offset two lines. One is 4 cm, another one is 3, and create this diagonal line. And this will represent the boundary of the hand grip. Next I'm going to create the first profile of the hand grip. Here's the second one on the pinky finger. This side of the wall has to stay a bit upright. I make some adjustment on the angle here. Then I use the loft command to create a solid model of the hand grip and chamfer this corner. A fillet will give more round, smooth curve, but when printing, chamfer will give a better results. I will extend the two ends of the grip up to this point, also the bottom ends. Then I will create a sketch to trim it on both ends. Then I use the push-pull command to slice it. Now I have a grip. I will also round the four corners of the grip using 5 mm radius. Next I'm going to create a sketch to link the grip to the mounting bracket. Then I'm going to extrude it upward for about 3.2 mm. This joining part, it cannot be too tall because the tip of your finger is going to rest on it. So this groove cannot be shallow. And next I'm going to create a chamfer along this corner. At first I thought about adding a 1/4 inch blast thread insert here, but I realized many of you won't have a hot end large enough to press it in, so I will skip this part of the modeling. Here I add the text Pika on the top face because it looks really blank, and I think colorful text will make it look better. I extrude it as a separate solid, so if you live in Brazil, you can remove this text yourself and exclude it from the printing. These letters are isolated solid from the main body, and you can just simply delete it in the slicer. Here I found another problem where the joining solid is not touching the grip because the grip wall has a curved surface. So I use the slice command to slice the grip from the main body, and then I hide it. Next, I extrude the face here, extend it just for a few millimeters, turn the grip back on, and use the union command to join them again. Now it's perfectly joined. And I use the push-pull command to repair the imperfection. Okay, this should be ready for test printing. I have this new support interface filament from Bamboo to try out. It's compatible with PLA and PETG, and let's see how easy the support can be removed when using this as the interface material. In the slicer, I set the letters to a different material color, and then I apply the Bamboo interface filament as shown with the red color. I also use the support ironing and set the top C distance to 0. This interface filament feels a bit softer than PLA and PETG, but it's harder than the TPU. The prime tower doesn't fail when using with this filament. Here's how it looks. Now the printer is doing the support ironing. Here's a support that has been ironed. It's not perfectly smooth. The print took 2 hours to print with 3 different filaments. Let's see how easy it is to remove the support. And the support popped right off, but I didn't get the shot. Here's the interface side. It's not perfectly smooth as I expected. To fit the magnetic ring into the bracket, you need to use the adhesive. And I'm going to keep it compressed with a small C clamp. Here's the 1/4" brass insert that I was intended to use it in the first place, but the MagSafe can't resist the rotation. So I went back to BricsCAD and I will create a mechanism that prevents the bracket from rotating. And the Pika has a certain amount of weight, and when you hang it on the top of the phone, it can create torsion that the MagSafe cannot resist. So I simply create a small box and use the subtract command to subtract and separate the excess body and delete it. Then I increase the thickness up to here, and then I create a 60-degree dovetail. Use the profile to cut it and offset it for 0.1 millimeter for the clearance, and extrude it to about here so that I can have the tolerance for adjusting. Okay, next I'm going to create this profile so that it can interlock with the bottom side of the phone, and this should stop the MagSafe from the rotation around the corners. So this bracket should have a few millimeters of adjustability. Okay, this time I print without using the interface filament. The support setting is set to the default value. And the support finally come off. A bit harder to remove than using the Bamboo interface material, but it prints faster, and the end result of the surface looks pretty good. I think if you can keep your filament dry, you are not going to need the support interface material. Here's from the standard setting. Here's the second one without the hand grip. Let's try to remove it. I also not using the interface material and use the default setting for the support, and it come off very easy. So if your filament is dry, there is no reason to use the more expensive interface material at all. Here I put the magnetic ring the wrong way. It's supposed to go the other way. At least I realized when the adhesive haven't cured yet. So I put it back on this side. And here's the retainer. It should prevent the magnetic ring from rotating when it sits on the side of the phone like this. So I will put a small dab of glue on this side of the retainer and slide it in. And make sure that your bracket is stand upright. Okay. And when I place it on this side, it won't rotating anymore. So the retainer works well and the grips feel comfortable to hold. I connect the scanner to my phone and then I will do the scanning test. Let's try this with the car grab handle. I'll scan with the 7-line lasers and use the 0.2mm for the resolution. With the hand grip, I can hold the phone securely in one hand while using the other to rotate the turntable. I use this grab handle for a reverse engineering course in a future video. That's one thing to know, that some part of this grab handle has a translucent plastic and the scanner cannot capture without using the spray. I didn't use the spray, so that part won't be captured in the scan. So with this setup, you cannot connect to the scanner using the USB-C cable because it's going to stick out from the right hand side. And I have heard that in the next mobile app update, the Pika will run at 100 frames per second using the USB-C cable on a mobile phone that use the Snapdragon X Gen 5 CPU. Right now with the Wi-Fi, it runs at 40 frames per second. So if you are planning to purchase the new mobile phone for using with the Pika, I would recommend that you focus on the Snapdragon X Gen 5. Okay, I flip it over to scan the opposite side. First, you need to look at the 7-line laser, the green lines, and adjust the length until it appears on the object surface. Then you can tap on the start button. In my opinion, the current scanning speed of the Pika on my mobile phone is very good. And yes, you get a little less resolution comparing when connecting to the PC, but the gap will be narrower when you scan with the lower resolution like this one, 0.2mm. Okay, next let's try without using the hand grip. I also have a version without the hand grip. So when you hold it, you need to put your pinky finger to support the phone and put your thumb above it. So it's not as secure as holding with the hand grip. And when you hold it long enough, your pinky finger will get tired. It's light, but it's almost 600 grams. You can still turn your scanner portrait or landscape, but I don't recommend using this version. It's no grip. Okay, let's do the post-processing from within the phone. Tap on Edit and use the lasso tool to select the scan data from the top. Click on Invert Selection and delete it. And next I'm using the lasso tool to select the remaining turntable and tap on Delete. Okay, next move to the second scan. Tap on Edit, select the lasso tools, Invert Selection, then use the lasso tools to remove the remaining turntable. Select both scan, tap on the fusion, and I set the resolution to 0.2mm and check the remove marker. I do this with the second scan as well. Select the resolution and then click on confirm. Now we have two scans that need to be aligned together. Tap on alignment and tap on auto alignment. This grab handle has a lot of curvature, so it might be possible to align with two scan dataset, and it actually does that perfectly. Alignment. Next, click on mesh, and I'm going to mesh with 1.2 million faces. Click on apply, and here's the mesh result. This version of Creality Scan app can do almost everything the PC app can. It's fast and very responsive. Next, I'm going to send the mesh data to my PC. Tap on the share button, select the single model, then select the mesh. Then select the file output type. I'm gonna choose OBJ, tap on share, and I'm going to use the quick share to send it to my PC. And here's the scanning result from the Pika using a mobile phone. I can confirm there is no other 3D scanner that works this well with a mobile phone. The results are almost as good as scanning on the PC. As I mentioned earlier, some brackets are made of translucent material, so they can't be fully captured without applying spray. I add a download link in the description for the phone bracket step file, so you can modify it to fit your phone, and also for the point cloud in case you like to create your own model. Thanks you guys for watching. I'll see you in the next video.